Hello everyone, Assalamualaikum. We are now going to continue with the topic on currents in BJT. We have learned that BJT in active mode has the EB junction in forward bias and CB junction in reverse bias. We have discussed on the current flow during the active mode, of which the carriers from emitter is injected to collector, passing through a thin base and moving to the collector. In the base, since it is very thin, thus the recombination that happens in the base is very small. This recombination results in base current IB. So for an NPN BJT, as in our example here, there is a collector current IC and base current IB that flows towards the emitter. So in this subsection, we will discuss further on the BJT current components and the current gains. There are three current components in BJT: emitter current, base current, and collector current. Emitter current consists of the current resulting from electrons injected from emitter into base, INE, and the current resulting from holes injected from base to emitter, IPE. Base current consists of the current resulting from holes injected from emitter to base, IPE, and recombination current happening in base, I recombination, subtracting the hole current due to the extracted holes from collector into base. Collector current consists of hole current due to the extracted holes from collector into base, IPC, and the electron current from electrons that cross the base and enter the collector, INC. So, let's take a look on emitter current. At the EB junction under forward bias, there are Ne electrons that are injected into the base from emitter. This electron's movement will generate an electron current, INE, that moves from base to emitter. At the same time, there are PE holes that are injected from base into emitter. This hole's movement also generate a hole current, IPE, that is also moving from base to emitter. So INE and IPE will become emitter current, IE. While the electrons from the emitter pass through the base, a very small quantity of the carrier recombines in the base region. This contributes to the base current, while the majority of the carrier reach the collector and contribute to the collector current, IC. Collector current is made of the electron current, INC, and hole current, IPC. The hole current can be divided into two. I'(PC) is due to the generation and recombination in reverse bias CB junction. I'(PC) is current from extracted holes from collector into base. On the other hand, the electron current, INC, is the current generated from the electrons that cross the base and enter the collector. Looking at the Venn diagram, we can see that there is INE, which is the electron current that is from the electrons that are injected from emitter to base, and there is IRAC, which is the current due to the recombination of electrons in the base. Thus, INC can be given as INE minus IRAC. Base current has three components: holes injected from base into emitter, IPE, electron-hole recombination current in base, IRAC, and holes extracted from reverse bias CB junction. Generally, base current is very small, in the order of 100 times smaller than IE. Almost all IE will become IC. Thus, we can also say that IC is 100 times larger than IB. This figure depicts the magnitude of the current components in BJT. We have the emitter current, IE, that can be given as IC plus IB. At the same time, IE is the total of INE plus IPE. IB is IPE plus the recombination current minus the hole current from the collector, IPC. IC is made of INC and IPC. And INC combines with IRAC, we can get INE. General observations on the current's relative magnitude can be given here. Since emitter is heavily doped, INE is much larger than IPE. Since base is made thin, so the width is less than the electron diffusion length, thus Irad in base is small, in which Irad is much smaller than IE. Since Irad is negligible, INC can be equal to INE. In active mode, since reverse bias leakage current is in the order of microampere and IC is in the order of milliampere, IC is almost equal to INC is almost equal to INE, and IPC is very small. Next, let's take a look at the common circuit configuration of BJT. First, the common base. For common base, the base is connected to the ground, or the base is the common node to the power supplies. For common base, the input is the emitter current and output is the collector current. The gain is given by output current divided by input current. Thus, in this case, the current gain for common base alpha is given by IC over IE. IC is usually smaller than IE because some of the injected carriers from the emitter recombines in the base. But since the base is made very thin, the fraction of the recombined carriers is very small. Thus, IC over IE will result in a number that is almost equal to 1, usually in the order of 0.99. The second common configuration is common emitter. In this case, the input is IB, base current, and the output is IC, collector current. The common emitter current gain is beta, given by IC over IB. Since IB is very small, thus beta is typically in the order of hundreds. So to summarize the current gain, the BJT current gain for common base is alpha, which is given by IC over IE, since IC is the output and IC is the input. In common emitter configuration, the current gain is beta, which is given by IC over IB, since in this case, IB is the input and IC is the output. Beta is large, typically in hundreds. Alpha and beta can be related as shown here. So in order to have a large beta, alpha must be very close to 1. Alpha can also be expressed in various current components. It is the product of injection efficiency, gamma, transport efficiency, alpha T, and collection efficiency, M. Each of the component is made of various current components, and these equations are useful in your calculation. To summarize, there are three main current components in BJT: emitter current, base current, and collector current. Using this figure, hopefully you can explain the component of each current. And there are two circuit configurations that were discussed, which is the common base and common emitter configurations. The current gain for common base is alpha, and current gain for common emitter configuration is beta. Alpha is typically in order of 0.99 and beta is usually in order of hundreds. And alpha and beta relation can be expressed as beta equals to alpha over 1 minus alpha.